All right, welcome to 4.3 Proving Triangles Are Congruent. Remember the definition of congruent triangles says all the corresponding parts of the triangle must be congruent. Okay, so the parts were sides and angles. So we had to show 6 things to use that definition. Now, today we're going to talk about some shortcuts. There's 2 postulates where we can prove triangles are congruent with only 3 things. So it's about half as much work. And the first one is the side congruence postulate. We abbreviate that SSS. So that stands for side, side, side. Side, side, side. And basically, if all 3 sides of one triangle are congruent to 3 sides of a second triangle, so this side congruent to that one, this one congruent to this one, and the third side congruent to the third side, then the triangles are congruent. We don't have to worry about any of the angles. The second postulate is the side angle side congruence postulate. So here we need a side, an angle, and a side. Now the angle being between the 2 sides is pretty important as we read through here. If 2 sides are, and the included angle. Included angle means the angle between the 2 sides. Okay, so for example, if we know this side is congruent to this side is congruent to this side, the included angle would have to be this angle right here. Okay, this angle and this angle are not between the 2 congruent sides. Okay. Then the 2 triangles are congruent. So different things we could do if we know all the sides are congruent. It's congruent by side, side, side. If we know 2 sides and 1 angle between the 2 sides, it's congruent by side, angle, side congruence postulate. So here's some examples, 4 examples, where we can look to see if we have some congruent triangles. And now, if we don't get a whole lot of information on any of these, we might sometimes have to figure something out. Okay, so for example, in number 3, I look at this, I know this side's congruent to this side's congruent to this one. I know my third side, right? This side, since it's being used once in the green triangle and once in the blue triangle, right? This side is congruent to itself. Okay, that's by the reflexive property. Okay, that side is congruent to itself. So now I know all 3 sides. This is congruent to itself, the green and blue triangle side. This one to this one, this one to this one. So this is yes by side, side, side congruence postulate. Those 2 triangles are congruent. All right, if we go over here, once again with the reflexive property, this side is congruent to itself. So I have this triangle, and I saw that the reflexive property, this is congruent to itself. So now I look and I have one side, an angle, and a side. This angle is between the 2 sides. So these 2 triangles are congruent by the side, angle, side congruence postulate. Okay, and if we come back up here, I'm not sharing any sides, so I'm thinking, okay, I don't know anything about this side here. Okay, I don't know that length. But do I know anything about the angles? Don't know anything about these angles, but can I figure something out about these 2 angles? And they are congruent by the vertical angles theorem. Okay, so I'm going to try to write this stuff in here. So this is vertical angles theorem. That angle is congruent to this one, and this is the reflexive property. Alright, so now I have a side, an angle, and a side. This angle is once again between the two sides, so these triangles are congruent by side, angle, side, congruence postulate. And we get back up to the first triangle. I know two sides, so I'm thinking I either need to know my third side. Do I know anything about these sides? No. Or I need the angle between the two sides. Do I know anything about this angle and this angle? No, I don't. So these look like they are congruent, but you never know. This, this angle might be a little bit off, right? This side could be congruent to that side, this side congruent to itself, but these triangles would not necessarily be congruent. So you got to be careful. Don't assume that just because they look congruent, okay, they look like they're the same triangle, we can't prove it. So are the two triangles congruent? No, we don't have enough information. Okay, no. And then simple no would be good, but I'm going to write not enough info to show it. Okay. And now we got a couple quick proofs. Basically, I kind of walked through some proofs, but as we start this, I'm using these congruent tick marks. All right, so prove triangle ABC congruent to DEC. I'm going to start off with saying segment BC is congruent to CE, and given 3 lines, so I'm going to need to say also AC is congruent to CD, given. Okay, that's what those tick marks are saying. 2, I got 2 sides. I need either an angle or the third side. The angle would have to be the included angle between the two sides. Okay, this angle is not between the two congruent sides, nor is this one. This would be the angle between. I don't know anything about these sides, but I do know that this angle and this angle are congruent. Okay, angle BCA is congruent to ECD. And why is that? Vertical angles here. Angles. And now I have a side, the angle between the two sides, and another side. So this is the side, angle, side. Oh, hold on. I'm putting it in the wrong spot. I have what I'm trying to prove, triangle ABC is congruent to, now angle A corresponded with angle D, so B corresponds with E, and AC corresponded with itself, C. So I double check that worked right. The corresponding parts are congruent, and now the reason is side, angle, side, congruence postulate. Similar proof, okay? I'm going to probably just walk through this one, but I'd put my givens down, okay? And then, so I would have 2 sides. I'd have a side and a side. I either need a third side or a third angle between them. I don't know the angle between these two, but I do know that this third side is congruent to itself. Okay, so I would say BC is congruent to BC. That'd be my third side. And the reason for that is the reflexive property. And then I could say the triangles are congruent. And the reasoning for that would be side, side, side. I believe this is the last example. And they want us to use side, side, side congruence postulate to show the two triangles are congruent. So they want us to basically find the length. This is kind of what you call a coordinate proof. We'll be doing this a lot in the end of the chapter, but it's a nice introduction now. If I want to find the length of AB, this one I can just count, right? AB has a length of 4, and AB is going to correspond with the triangle ABC. Segment AB corresponds with XZ, where B and X are my right angles. So B, X has to go in the middle, Z, Y. That's what I'm going to try to show. But I need to find these lengths. This has a length of 4. You can just count it. This has a length of 6. This has a length of 6. So right now I have, by definition of congruent, definition of congruence, that since they have the same measure, AB is congruent to XY, BC is congruent to XZ, BC is congruent to XY, and now I have to show AC congruent to ZY. And I would basically say, by the Pythagorean theorem, right, you can use the distance formula, but if you know these lengths, just use the Pythagorean theorem, a squared plus b squared equals c squared, right, or the square root of a squared plus b squared. So 4 squared plus 6 squared, 36 plus 16. We get 52. So that's the length of these sides. So since they both have 4 and 6, we know, basically because this is right triangle, right, that third side is going to be congruent. All right, have a good night.